Hi, welcome to yet another episode of RTG. Today we solve a very interesting problem, the problem named task scheduler. Basically, you are given an array of CPU tasks where task is in uppercasing this character from A to Z. You are also given an integer n. Each CPU cycle allows the completion of single task and tasks may be completed in any order. Nice. The only constraint is that identical tasks must be separated by at least n CPU cycles to cool down the CPU. Means to we can't have two consecutive tasks, same task, until unless there is n gap between them. Just say n equals to 2 is there, y is there. So we can have x, but we can't if we have x as t equals to 1. We should have x, another x after t equals to, what do you say, 1 plus 2, that is 3. So basically, you can go for x, then y, this is t plus 1, this is t plus 2. Then add t plus 3, you can have it. Okay, so minimum 2 gap should be there. That's what it is written. That must be separated at least n CPU cycle. So this cycle should be there. So I think this problem is uh, mostly you have to first of all think, just if you think about the intuition, what goes down the problem, you think that, okay, I will try to have those problems first, those tasks first, which are have greater frequency in order, right? And we'll try to incorporate the tasks which have less frequency than that in between. Somehow we'll manage like this. Just say ki if we have 4x and 2y's, so what we can do, and if we have 3x and 2y's, so obviously you want to start with the more frequency one, such that we can do something like x, y, x, or something like that. Okay. And if it is not possible, we need to incorporate the idle time between idle in between also. Okay. So this is the intuition, but there is more about the intuition. First of all, you have to think that we should take the current one with the max frequency. First intuition. Second one is that which is the next one into that. But again, you have to think that is it like the cooldown happened? Like in this, let's say XXY is there, so both have the max frequency. Like let's say triple ABC, okay, and n equals to 3. So the point is you can go with A, then you can go with B, then you can go with C. But again, can we go with A? I mean, B का cooldown नहीं हुआ था, C का cooldown नहीं हुआ था, ठीक है? So it's fine. So we'll try to first have all until unless no cooldown happened. But in the next iteration, when I ask you that now अब तो सबका हो गया है, like let's say the cooldown of B happened, C happened, all this happened. So what next you can do? Obviously A, because A was the last that happened. So there is more probability कि A का cooldown खत्म हो गया होगा. But you have to ask somewhere ना कि भाई A का cooldown खत्म हुआ है कि नहीं हुआ है. So you'll see कि दो ही टास्क अभी हुए बाद में. At least three होने चाहिए थे. So no, you have to wait one more time, then we can take A. Then again for B you have to ask कि बीच में can I do B? But B तो है ही नहीं हमारे पास. C भी नहीं है, फिर A ही है. A के cooldown के लिए अगेन तीन वेट करना पड़ेगा. So this is how it happened. So we have to maintain one priority queue for the max frequency one, and one queue we need to happen where we will find that key cooldown is happening or cooldown has completed. Okay. So basically int I will say sj equals to tasks dot size, and I will first of all I'll have a map to get all the frequency. Okay. Basically for int I equals to 0 I less than sj I plus plus. I mean, when in interview, if someone asks you, you should code like, I mean, super fast, because nowadays expectation is like you should code it into 2 minutes. Okay. I don't know what is the expectation nowadays. So we maintain a priority queue. C++ priority queue is max priority queue only by default priority queue. So we'll make a priority queue of int pq and we'll just insert all the frequencies down here. Okay. So for auto IT to the map, and we'll just insert all the frequency here, pq dot push. I think IT dot second, if I'm not wrong. Yeah, sorry, IT dot second. Yeah. Now you have to maintain one queue for maintain a queue for cooldown period. Okay, for cooldown uh period. Okay. So we'll maintain a queue of pair of somehow int command. Int is the frequency you can say, and second is the time. Okay. By time, what I mean is. I mean, it's a first in, first out, right? So you'll always try to see the top of the queue, like what is the last one inserted that can we use somehow. So this is all. So till while pq dot empty and or cooldown is empty. Okay, if anyone is non-empty, we will still continue because we are still ready to go, right? And in time equals to zero, that will return in the end. And so time has started time plus plus, and now we'll check if pq dot empty, if pq is not empty, like if the particle is non-empty. Okay, so I will just see that int car equals to pq dot top, and yeah, int car equals to pq dot top, then pq dot pop, and basically I will decrease the frequency. I will say that car minus minus. I can say that you can say frequency. This is a frequency, right? And I will decrease the frequency. Okay. And if frequency is greater than zero, if frequency is greater than zero, so I will say that now it go into the cooldown, right? Cooldown dot push. The frequency will go into inside it, and the time plus n, right? Because now at this time, uh, let's say t equals to 2 you came, okay? So I already increased t equals to t plus plus. So now at this time, t3 happened, and now t3 plus 3, 6. So this time it will eventually go into the complete the cooldown, okay? So or you can, let's say, don't increase the time here, and time plus n plus 1. I mean, this time to bhai, we can use it, right? So this is there, and we'll check that if cooldown is not empty, let's say if I will check one thing, that if cooldown uh, down is not empty, so and we'll check that if I mean, just find it autocur equals to, I'll just check the top one, right? It means the oldest one, that cooldown dot uh, top, I can say pq dot top, q dot front, or q dot back, q dot front, I think. That what is the, because first in first out, so I want to see at the front, right? So car equals to cooldown dot front, and int check time equals to, I think, car dot second, and car dot second, and we'll check that if check time equals to our time, which is currently, so then you can obviously pq dot push uh, the frequency from here, which is the cur dot uh, first, I think. Yeah, that you can do, and you can cool down dot pop. Yeah, q dot top, q dot pop, I think also happened in stack also, but q dot pop, okay. And this happened, and now you can increase the time, okay. I think you can increase the time here only, because if it is not empty, we used it and we put into the cooldown, okay. And now since we put in the cooldown, the time is already increased, time plus plus. And now you can check from here that if cooldown is not empty, we can check with this time. Okay, that is this time happened or not. Because here, let's say you, I just dry run the code. I just dry run the code like this. Like first you came as t equals to 0, then obviously you had this. So when you go into this, you check, okay, now it's t equals to 1. Now you have this, and you put into the queue that, okay, is a, you can use another a at time equals to 0 plus 3 plus 1, 4. It means time equals to 4, right? So see, 1, 2, 3, 4. Yeah, 4 you can use. Okay. But time is to one now. Okay. So now you can check that obviously cooldown is non-empty, but in cooldown, if you will check that is time equals to 4 now? No, it's time equals to not equals to 4. Another and the next you will go is you will use the B, and when you use the B, you will put the frequency against becomes zero. So you can use another at the time is to 4, okay? And when you use it at time is to 4, you can push, and when you go time is to 4, you put, then you can 4 plus 3 plus 1. Basically, time is to 8. So 4, 5, 6, 7, 8. This is how you can do. Okay, you can check. So that's why I did time plus plus after putting into the cooldown, and I check cooldown after doing the time plus plus. That now because we'll take into consideration into this time because obviously we're not using this, we'll use it in the next iteration. So we can use it that can we put it or not. So that's why we returned time here. And I'll just try to run this code and we'll check it. Okay, cooldown dot pop. What is the okay? There seems like some compilation error. Tasks dot size. Wait, yeah, I think this is the tasks dot size and I think into cooldown also some there is an issue here. Cooldown dot empty and cooldown and cooldown is there. Try to run it again. Okay. I think you check the queue first when it slice. Queue of pair, comma. Wait, I think int comma end. Now it should be fine. Yeah, accepted. I'll try to submit it. Yeah, nice. So this was the problem where you have to maintain a priority queue in a queue to find when you can use the next task. So this was for it. If you have some valuable insights, you can ask me in the comments. Till then, we'll meet in the next one. Till then, bye bye.